Hello everybody, welcome back. So we just took a look at naming acids. So you should have watched that lesson and taken your notes before coming to this one. So now that we've learned how to name acids that contain both oxygen and that do not contain oxygen, let's take a look at going backwards and then writing the formulas for acids when given their name. So basically we're just going to be working backwards. So remember, we just learned that the prefix hydro lets you know that the acid is binary and that there's no oxygen present. Okay, so when we talk about a binary acid, that means there's going to be basically two elements involved, right? Bi means two. So hydro is letting us know that it's a binary acid and that there's no oxygen present. So once you determine that there's going to be no oxygen, and you're going to be dealing with a binary acid, you need to determine whether or not you need to crisscross the charges of the hydrogen and the nonmetal, because you want to wind up with a neutral compound. Okay, so let's look at hydrobromic acid. Okay, so the hydro is going to let us know that there's no oxygen involved, and bromic, we know that the anion involved in this acid is going to be bromide. Okay, or bromine. Bromide is the anion, bromine is the element. Okay, so the acid does contain the hydrogen ion and the bromide ion. Okay, so let's take a look at those off of our periodic table. And again, anytime you guys are watching these lessons, you're going to want to have your reference tables in front of you. So if we look at the charges typically on our hydrogen and our bromine, we find that hydrogen is a 1+. We know that already. Remember, hydrogen's in group 1. And then bromine's going to be a 1- charge. So he's going to tend to take on 1 electron to fill his outermost valence shell. So a 1+ and a 1- cancel each other out. So the two charges add together to get 0. So our formula for hydrobromic acid is going to be HBr. Okay. Now, if they did not cancel out, you just have to perform that crisscross method to kind of work backwards and figure out how many of each atom you would need. Okay. So let's write the formulas for the following binary acids. So here we have a hydrocyanic acid, right? So cyanide and hydrogen. Hydrogen is going to have a 1+, all right? And cyanide is going to have a 1-. So when we look at that, our final formula for hydrocyanic acid will be HCN. Okay, so hydrogen attached to cyanide, the cyanide anion. So remember, again, that hydro prefix is letting you know there's no oxygen and we're dealing with a binary acid. Here we have hydroselenic acid. So if we look at hydroselenic acid, we know that we're going to have hydrogen, right, attached to a selenium. So if we have hydrogen and selenium, so here this is a little bit different. Here we had to do our crisscross method to figure out how many of each atom that we need. Here we've got an H2SE. Okay, so what this is telling me, right, if we go to our periodic table and we find selenium, what we should see is that selenium would have a 2- charge. Why would selenium have a 2- charge? Well, again, if we go back to thinking about our ions, right, selenium is in group 16. So if selenium is in group 16, that means that selenium needs 2 electrons to fill its outermost valence shell. So it's going to take on 2, okay, which gives it a 2- charge. So if selenium has a 2- charge and hydrogen has a +1 charge, in order to get this compound to be neutral and to equal out, you need to do your crisscross method and find that hydrogen will need 2 hydrogen, so his overall would be 2+, and then selenium would be 2-, and so we've got an H2SE. So that's hydroselenic acid. So working backwards for writing the formulas for acids with oxygen. So remember, if there's no hydro prefix, you can pretty much tell that there's going to be a polyatomic involved that has oxygen in it. And just for your other acids, you're going to determine whether you need to crisscross the charges of the hydrogen and the polyatomic. Remember, the charges for the polyatomic apply to the whole molecule, so the big molecule. So let's take a look at acetic acid. So we know, again, from our previous lesson, that if an ion ends in an ATE, so if a polyatomic ends in an ATE, the acid has to end in an IC. So since we've got an acetic acid here, IC, we're going to be dealing with the acetate polyatomic ion, okay? So the acid is made of H+ and the acetate ion. And again, your polyatomics are in your reference table. So here we've got our hydrogen, which is a 1+, and then the C2H3O2, that's your entire polyatomic. That 1- charge applies to the whole polyatomic. And again, you can find that charge in your reference table. So the 1+ and the 1- cancel out. This is a neutral compound, so that is your formula. So you've got HC2H3O2. That is your formula for this acid. Okay, so let's write the formulas for these. We're looking at iodic acid, right? So iodic acid, IC, right, is going to be our indication that our polyatomic is ending in an ATE. Okay, and there's no hydro, right? So we know that we're going to be dealing with a polyatomic attached to a hydrogen cation, okay, and we will not be having there will be oxygen present, okay? So if we've got iodic acid, we know that the IC ends in an ATE, so the original anion would have been the iodate. Okay, so the iodate polyatomic. And we know that iodate, based off our chart, is IO3 with an overall negative charge. Okay, and again, if you don't know where I found that, that's in your reference table. So we've got IO3 with a negative charge, right? And our hydrogen is going to have a positive charge, so we don't have to crisscross anything here. So our final formula will be HiO3. Okay, so here's your hydrogen, here's your polyatomic to give you iodic acid. Remember that IC comes from the iodate polyatomic. Okay, all right, so that's working backwards to figure out your formula from the acid name. If you guys have any questions, let me know. At this point, your notes should be done for both naming your acids and then finding your formulas. So you can go on back into your assignment for today and complete your practice problems. It's just a checkup. It looks like a quiz, but it'll be an informal grade. You can take it twice, and the highest grade will go in the grade book. If you guys have any questions, let me know, and I hope you all have a really great day.